All right, so we're going to be picking up in your workbook on page 268 with simplifying rational expressions. We learned on Tuesday night what a rational expression was. So it's a fraction, basically, with algebraic expressions involved in the numerator and or the denominator. You treat these rational expressions the same way that you treated fractions when you learned to do fractions way back many moons ago. All the rules that apply to normal numerical fractions apply to algebraic rational expressions. Okay, so if you can kind of go back to that, then it'll lead you into what we're doing. So that's what we're going to start with. We're going to start with one that's just normal, a number. This is something like we worked with in middle school, 35 over 75. So if I asked you to simplify this, now when I was growing up we called it reduce the fraction to lowest terms, but things have changed and the younger generation calls it simplifying a fraction because that's more educated and we want our students to use educated words. So whatever you call it, fix it, right? That's what you got to do. You got to fix it. So you got to make it where there are no common factors in the numerator or the denominator. You may immediately know what the greatest common factor is of both of those, and you may not. So you just have to, do what you know, and if you don't know, then you break it down into its prime factorization. So you could write this, if you wanted to, as 5 times 7, and then we can write 75 as 5 times 3 times 5. So I wrote it as a product of prime factors, okay? And then you cancel any of them that they have in common because 5 divided by 5 is 1. So your answer is 7 over 15. Now don't have the answer to that. If that's not right, please speak up. Okay? And I don't have a calculator up here. I'm just kind of winging it. So that's the process. Now I knew that they were both divisible by 5. Probably most of you did. So you would have just typed it in your calculator real fast and got 7 over 15 and went, oh, well 7's prime and 15's not divisible by 7, so I'm finished, right? Okay, the same process you will do with rational expressions. So let's look at this one. Oops, I wrote it wrong. Sorry. It's just a. It's a, b to the 5th, c to the 5th. Okay? So as you look at this, you're supposed to try to cancel any like factors that they have. I do want you to notice that this is a monomial, this is a monomial. A monomial means it is a product of numbers or variables, okay? You do not see any plus signs, minus signs in here. It's straight multiplication across the top and the bottom, right? All of these things are multiplied by each other, and so that means they're all factors of the entire expression. So I could say 15 is a factor of 15a cubed b to the 6c. a to the 3rd is a factor of this, so forth and so on. Okay, so you can cancel factors freely, meaning if it reduces or simplifies, go for it. A top to a bottom, any top to any bottom, any numerator to any denominator. So let me pick up a different color here. All right, what are 15 and 10 both divisible by? 5. So 5 goes into 15 3 times, and 5 goes into 10 2 times. So you want to go ahead and do that. Now these can get really messy with your, marking out. So just, if they do get too messy, just rewrite it and then, mark on that one a little bit. All right, so I've got an a to the 1st and an a to the 3rd in the bottom. Now, you know this is an understood one, right? Okay, let's come off to the side and think about this. Let's look just at the a's. Okay, so I have a to the 3rd. That means a times a times a. And I have an a on the bottom. So I'm only looking at the a's just as a teachable moment. Okay, what cancels here? One of the a's. Okay, so I'm left with what? A to the second, where? In the numerator, right? Now, there's a rule for this, and I'm not sure if you've been exposed to them yet or not. I don't think you have. But if you have a variable with exponents on the numerator and then the same variable in the denominator, you can just subtract the exponents. Is that true? 3 minus the understood 1, did that leave me with 2? Okay, so that's the rule. If you're dividing like bases is what we call them, you can subtract the exponents. So this one will cancel into a to the third and leave you with a to the second. And you can mark it like that, or you can rewrite it, whatever you're comfortable with. Now I have a b to the fifth and a b to the sixth. So if we use that, if we think about it, there are 6 b's in the numerator and there are 5 b's in the denominator. So the 5 in the bottom are going to cancel into 5 in the top, and how many will be left in the top? Just 1. So b to the fifth goes into b to the sixth and leaves you with a b to the first. You can just mark it out if you want to. And now I have c on top and c to the fifth in the bottom. So you use the same process, but where will your c's be at? In the bottom, that's right. So c goes into c to the fifth and it leaves you with c to the fourth. And I could have just marked out the exponent and put a 4 like I had been doing. So my answer is 3a squared b over 2c to the fourth. Is that correct? Okay. Now, if the expression contains no plus and minus signs in it, then this is just cancel. Just start slashing stuff out, okay? When you get into binomials or trinomials or any form of a polynomial being in your numerator or denominator, meaning that you have more than one term added in there, so like x plus 2 over x squared minus 16, you have to factor before you can cancel, because you got to write them as a product. Like these are all times each other and we could cancel freely. That's what you've got to do with polynomials, okay? You've got to get them something times something, and then you can cancel the like factors. We have to factor them before we can cancel, because we have to write something as factors means to write them as a product, something times something, so that you can only cancel factors. You can never cancel terms. Let me give you an example. One thing I see students do, this is wrong, so don't copy this down yet, just watch it, okay? I see students do this. The answer is 2/4, which reduces to 1/2. This is wrong. This is very wrong, okay? These are terms. They have a plus sign between them. If this were x plus 2 and this were x plus 2, then yes, I could mark the entire x plus 2 out. But you can't mark out terms, okay? So if there are plus signs separating them, and you can't mark out the whole quantity that has the plus sign in it, then do not cross it out because it's wrong. All right? Just like up here, I mean, I could have said this was 3 plus 32, and this was 3 plus 72, right? Could I have said that about these two numbers? And then mark off the 3's, and my answer is 32 over 72? That doesn't equal 7 over 15. You can only cancel factors, things that are multiplied. Okay, so remember, this is wrong. That is wrong. Don't do that. Okay? All right, so let's look at one like that. 2x minus 6 over x squared minus 8x plus 15. Here's an example of what you cannot do. I can't go, oh, 2 goes into 8 4 times. 6 and 15, they both have factors of 3. No, you cannot do that because this 6 is being subtracted from 2x. This is one quantity here, so you can't cancel part of it. But what I can do is I can write it as factors, and then if they're like factors, I can cancel them. So in my numerator, I see that there's a GCF of 2. So I'll factor the 2 out, and I'll be left with x minus 3. In the denominator, that's one of those trinomials that you have to factor. I showed you some techniques on Tuesday. You got x, you got x. Okay? Factors of positive 15 that add to be negative 8 are negative 3 and negative 5. Negative 3 times negative 5 makes positive 15. Negative 3x and negative 5x adds to be negative 8x. So that is it. Now you can cancel the entire factor of x minus 3 with this factor of x minus 3. And your final answer is 2 over x minus 5. Okay, so we're going to factor this, but we cannot cancel. Again, what's an obvious thing I might see a student do that would be incorrect? Mark off the x squareds. That's a no-no. That x squared is added to a whole bunch of stuff here. Okay? This one is too. It's one quantity. When you add things, you say, I have so much of one thing. So you cannot reduce it until you factor it. Okay? So with the 4 term, we're going to do grouping. Now remember, if there's a minus sign on the 3rd term, I always tell you to group it inside and stick a little plus sign in there for the time being so you remember that there's still addition in there. And we will factor it. So in the numerator, the greatest common factor is x squared. That would leave you with x plus 1. Here, this GCF is negative 4, so you're going to bring out a minus 4, and that's going to leave you with x plus 1. Distribute it to double check it if you don't believe me. Negative 4 times x is negative 4x. Negative 4 times 1 is negative 4, so we're good on that. This is one of those trinomials that's easy to factor. So it's x, and factors of 10 that add to be 7 are plus 2 plus 5. Okay, I'm going to come down here. So in the numerator, they have an x plus 1 in common. So I'll pull that out to the front. And that leaves you with the stuff that's in front of the parentheses in the next factor. X squared minus 4. Now, when I see this happening, I go, nothing cancels. Maybe I'm overlooking something. Did anybody notice anything in the numerator maybe that could be simplified even more? Right, that's a difference of 2 squares, right? We talked about it Tuesday night. So that part factors into x plus 2 and x minus 2. So now I have x plus 1 times x plus 2 times x minus 2 over x plus 2 times x plus 5 So you can cancel your x plus 2's, and that's really all that cancels. So your final answer is x plus 1 times x minus 2 all over x plus 5. You can put it in parentheses or not. You don't have to if it's the only thing that's down there. Okay? Now, some students don't understand why they don't go ahead and FOIL that back out. We just don't in math. We always leave things in factored form. I don't really know if your ALEKS will tell you to leave it in factored form or not, but generally speaking, this is how we would leave the problem. Okay? I just say don't create more work for yourself. Don't sit there and FOIL that out and just make it harder on yourself, you know, unless it specifically asked you to. All right, any questions on that? Okay, we're going to talk about how to recognize a ratio of -1. And ratios of +1. Let's start with +1 first. So let's talk about ratios of +1 and ratios of -1. All right, so a ratio of +1 is when you have anything over itself in a fraction. Okay, so if it's 5 over 5, that is a ratio of +1. All right, the same is true for algebraic expressions. If it's x minus 4 over x minus 4, that is a ratio of +1. Okay, simple enough on +1, right? With -1, and this is the important one that you recognize. So they start with this one just to kind of warm you up to the process of it. With -1, what you're going to see is opposites. So the opposite of 5 is -5. And when you put them in a ratio, that equals -1. The opposite of x minus 4 is 4 minus x. That's a ratio of -1. Okay? With subtraction, you know that it does matter what order you subtract things in. So like 1 minus 2 is not the same thing as 2 minus 1. They're opposites of each other. Well, that's what's going on here. Now, with addition, they are the same no matter which way. 1 plus 2 is the same thing as 2 plus 1. So you have to remember that as you're working with algebraic expressions. It all has to interconnect. Okay, so we got to make those little nerve synapses go fire and trigger and touch each other or whatever. I don't remember all my biology, but that's what you got to try to do, okay? Make it all connect. So these are opposites of each other. One thing I do want to say is we could write 4 minus x, just to help you further understand the opposites of it, as -x plus 4. Because the 4 is positive and the x is negative. And that might allow you to really see that x minus 4 and this are opposites because each term is the opposite sign, right? So just so you can connect that, maybe that'll help a little bit. All right, so let's look at this one. Identify if the ratio is equivalent to 1, -1, or neither. X minus 5 over 5 minus x. Is this equivalent to 1, -1, or neither? -1. That's right. Okay, what about this? X minus 3 over x plus 3. Neither. It's neither. Because they're not opposites of each other. So in order for them to be a -1 ratio, it has to be totally opposite. So the x is positive here, it's negative here. The 5 is negative here, it's positive here. So this expression is totally opposite of that expression. These are neither. The only part of these that are opposites are the 3. The x's are the same. Okay, so this is neither. All right, so we're going to simplify things in which -1, knowing a ratio of -1 is helpful to us now, okay? Simplify the expression, x squared minus 36 over 30 minus 5x. So we know we have to factor them first. This is a difference of two squares, so it's going to factor into x plus 6 and x minus 6. Here, I can see that they have a common factor of 5. And so that would leave me with 6 minus x. So what you have to recognize is that x minus 6 and 6 minus x are opposites, totally opposites of each other. Your book calls them additive inverses of each other because if you added them together, you get 0. Okay? And when you divide opposites, you get a ratio of -1. So I can actually cancel these out, and what I will be left with is a factor of -1. So my answer is, and you have to distribute this -1 times this x minus 6. So it's going to be negative x minus 6 over 5. Maybe I should have put this step in there. This is my answer, of course, but maybe I should have done this for you. -1 times x plus 6, like this first maybe, just to make it a little more visible. And then you see you can distribute it to get this. Or there's also another form of the answer in which the negative just comes in front of the fraction, and you have x plus 6 over 5. So this answer and this answer are the same thing, where the negative is in front of the fraction. I'd just like for you to be exposed to different ways that answers can be written because you never know what you're going to see.